Okay, another example here for you. So far today we've looked at domain of rational functions. That domain, right, you focus on the denominator. Where does it equal 0? Well, those things are not in the domain. Then we did vertical asymptotes. Still, focus on that denominator. Where does it equal 0? Those are going to create vertical asymptotes for us. Now, horizontal asymptotes, there's a little more going on. So that's why I wanted to go ahead and make a short video where we could talk about it, look at a couple things. So, three cases that we want to look at, and it depends on the degree. How does the degree of this top thing compare to the degree of the bottom thing? And that's going to be the key. So let's march through this. So if the degree of the top is less than the degree of the bottom, so degree of the top, bottom, right? So top is less than the bottom. There's a horizontal asymptote at y equals 0. So that graph is approaching a line y equals 0. Let me just illustrate that. So let's say we had something like 5x plus 1 over 2x cubed minus 5x squared minus 3x plus 7. I'm just making a polynomial up here. So that's our rational function, let's say. So degree of the top, oh, it's just a 1, right? Degree of the bottom is a cubic, so it's a 3. So the top is less. This would have a horizontal asymptote of y equals 0. Why is that? Well, I want you to think about this function. As you plug bigger and bigger values in for x, what happens? Let's say I plugged in 100, 1,000, a million. Well, this gets pretty big, right? It'd be 5 million plus 1, so basically it's 5 million. Look at the bottom, though. X cubed, this dominates these other ones, even though this is minus minus. A million cubed minus a million squared. The million squared doesn't make that big a difference. Excuse me. And so this would be, again, if I plugged in a million, this would be basically 5 million over 2 times a million cubed, which would be really big, right? And so this is getting, it's a number over a really, really big number, and so it approaches 0, basically. Hopefully that kind of makes sense. Okay, let's look at the next one. So if the degree of the top equals the bottom, so these have the exact same degree, well then you just divide the leading coefficients. So divide the leading coefficients. So what if we had something like this? So f of x equals 3x over 2x. I'll just do a nice simple one. Well, again, think about what happens. What if I plug big and bigger values into x? So like a million. Well, I get 3 million over 2 million. Well, the millions just cancel out, and you get 3 halves. It doesn't matter what that x value is, right? They're going to cancel each other out, essentially. And so you just get these leading coefficients. And so y equals 3 halves, in that case, is going to be our horizontal asymptote. So if they have the same degree, just divide the lead coefficients, and you get your horizontal asymptote. Okay, one last case to be aware of. What if the top is bigger? Okay, and we're talking degree. What if the top is bigger? Then there is no horizontal asymptote. Okay, let me illustrate that. Something like this. I'll do a simple one. Let's say we had like 2x to the 5th over 3x squared. Well, think about what happens. What if I plug bigger and bigger values in for x? Again, what if I plug a million in here? Well, a million to the 5th power over a million squared, and of course you could cancel these out, you just get x cubed, but you might have other stuff here. Well, the top is just getting bigger and bigger and bigger. It's actually going toward positive infinity in the y direction, and so there is no horizontal asymptote because the top grows faster than the bottom. Okay, so I hope that kind of makes sense. Write those down, keep them close, because we want to remember those, feel good about them. You're going to do horizontal asymptotes quite a bit. So let's go look at some examples together where we'll actually find some horizontal asymptotes.